What's good, what's good, what's good, y'all? In this video, we're going to talk about how to use for loops in MATLAB. A for loop is a special type of structure that allows us to repeat certain lines of code multiple times. Let's jump right into the syntax here. In order to use a for loop, we're going to type the words FOR, then we're going to type a space, then we're going to define what we call a loop index. This is a variable we're going to use to run through a predetermined set of values. After we've defined our loop index, we're going to set that equal to a row vector of desired index values. The moment I type for loop index equals row vector, this is going to indicate to MATLAB, please repeat a set of code that I type inside the loop body as the loop index runs through each individual value within the row vector on the right-hand side of this equal sign. The actual code that I want to repeat, I type into the loop body. That is the section of code between the initial for statement and the end of my for loop. Inside this block of code, we can include any executable programming statements that we want to repeat multiple times. The last thing that we're going to type when using a for loop is the word end, E-N-D, and that indicates to MATLAB that this block of code is a complete for loop. The best way to understand how the syntax works is to look at some examples. To do so, let's start a new script file. Let's save this under the title Play with For Loops. I save this to the current folder that I'm in, which is the one dedicated to this video. Using this script file, let's look at our first example of a for loop. Let's type the words for, F-O-R, then we type space. Now we're going to define an index variable. I'm going to call mine I. Then I'm going to tell MATLAB I want this index variable I to run through a predetermined list of values. The first value I want it to be is 1. The next value I want it to be is 2. Then I want it to be value 3. Finally, I want it to be value 4. As soon as I've indicated that I is going to run through the values 1, 2, 3, and 4, I'm going to push return twice, 1, 2. Then I'm going to type the word end. The moment I've typed the word end, MATLAB recognizes that this for loop starts with the word for and ends with the word end. Notice I can collapse that code as a single block that runs multiple times. Every statement that shows up between the word for and end is known as the loop body. This loop is going to be very simple. Specifically, all I'm going to ask MATLAB to do is to display the current value of I in each iteration. Let's think about this one more time. The point of this for loop is going to allow me to run this single executable line of code, which only displays the current value of the index variable I. This loop will run a total of 4 times because my row vector of desired value is of length 4. There are 4 separate values that we're going to allow I to take as this loop repeats itself. When I run this for loop, notice over here in the command window, we get some insight into what's happening inside MATLAB. Here we see that MATLAB has run the script file by typing the name. And then in this situation, we see that MATLAB is displaying the value of I in the first loop. So the first value of I was 1 because I ran through the value of the individual entries in the row vector. Then MATLAB runs through the second iteration where the index variable moved from the value of 1 to the value of 2. MATLAB ran a third iteration of this code, which is just display the value of I by updating the value of the index to the third entry in that vector. And finally, MATLAB runs through the last iteration of this loop and displays the final entry value in the row vector that I've defined. The next thing we're going to do is we're going to make the internal loop body a little bit more fancy. Right now, all we're doing is displaying the value of I in each iteration. However, we're going to add some contextualizing text to this by using the fprintf function. This function allows us to print a mix of characters and numeric symbols. Inside of this, let's go ahead and define a string. So we use 2 single quotation marks, and then we're going to write the value of index I is. The fprintf function is special because if I push $D, end the string, and then push comma I, MATLAB will insert into the $D the value of I during each iteration. Let's go ahead and run this. Notice the output that I got was really, really ugly. Specifically, look at this. The value of index I is 1. no space, no comma, no nothing. The value of index I is 2, etc., etc. One way to fix that single line of code printout in the fprintf command is actually to add a \n, and that tells MATLAB when you're producing this line of code, go to the next line every time this thing is called. Let's go ahead and clear this screen and rerun it. Notice this gives us a better indication of what's happening. The value of index I is 1, the value of index I is 2, all the way down to 4. With this, we see that this is a little bit more clear what's happening, but it still happens very, very quickly. Let's add a debugging feature to our for loop. So we're going to add the word pause with a semicolon. When we rerun this, at the end of each iteration, before we loop back to the top, we're going to actually get a pause. So let's go ahead and run. Notice what's happened here. MATLAB sets the value of my index variable equal to the first entry in my row vector. Then it pops into the loop body. It will run this line of code, which produces the value of index I is 1. Then it gets to the pause command, which actually pauses the execution of this code. When I hit the enter key, MATLAB recognizes that this for loop needs to repeat itself again. In other words, it's going to increment the value of the index variable from the previous value in the last iteration to the next desired value. So in this case, I goes from a value of 1 to the next value of 2. Then it will enter the loop body again, and it will print out the value of index I is whatever the value of I is. In this case, the value was 2. Then it moves down to the next line of code, which is a pause. So it's now waiting for me to tell it, please continue. So I push enter again. MATLAB increases the index variable to the third value in that vector, drops into the loop body, runs this print command, which is what we see. Now it's paused. When I run that again, MATLAB is going to take the index variable, let it equal to the last value in my vector, run this line of code and pause. At this point, when I hit enter again, MATLAB actually will do a quick check to see whether or not the index variable has actually run through all desired values. In this case, the index variable value of 4 was the last value that I want to run through in my loop, so MATLAB exits the loop accordingly. In this specific example, we've used a counting vector that starts at the value of 1 and then counts up by ones until we reach 4. But formally speaking, in this syntax, we do not have to count anything. In fact, we could define a vector that starts at 5, goes down to -1, goes to 10, maybe takes the value of pi, and then ends at 2 to the 10th. When I run this for loop, MATLAB is going to run through the loop body's code exactly 1, 2, 3, 4, 5 times, where the loop index variable is going to get the individual values defined by the entries of this row vector on the right-hand side of my equal sign. Indeed, when we push run, notice that the value of the loop index I in the first iteration is 5. It is the value of the first entry of my row vector. When I push enter to go to the second iteration, notice that I gets a value of -1. The third iteration is going to be 10. Could you guess what the value of I is going to be in the fourth iteration? Ding, 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 ding. It's the stored value of pi in MATLAB. And then finally, we get to the last entry of my vector. This is 2 to the 10th, which is 1024. MATLAB is stopped right here, waiting for the next command. When I push enter here, MATLAB does a quick check. Has I run through all desired values of my index variable stored in my row vector on the right-hand side? In this case, it has, because there are only 5 values, and so we exit that for loop. Let's do yet a further refinement of using for loops in this example. Notice that we could type out in a row vector the desired values for my index variables, but oftentimes in for loops, we're going to want to use the counting values. So start at 1, go up to 2, 3, 4, up to some value. In that case, we can take advantage of colon notation. Remember, if I were to say for I equals the vector 1 colon 10, this vector is going to be a row vector that starts at 1, goes up to 10, and increments in sizes of 1. When I run this code, MATLAB is going to run from 1 to 10 and just increment I accordingly. In this case, I'm going to go ahead and comment the pause out because we've seen how that functionality works. Let's run through this. Notice we got what we expected. The value of I ran from 1 to 10 in increments of 1, and that's because 1:10 is a row vector that starts at 1 and goes to 10. We could have equally started at 0 and gone up to 9 if we wanted to. When we run that, MATLAB starts the index variable at 0 and then runs all the way up until we get to the last value in that vector, which is 9. Now that we've seen this example in action, let's return to our general discussion of the syntax. In order to write a for loop in MATLAB, we're going to write the words for, space. We're going to define a loop index, which is a variable that is going to run through a predetermined list of values. That loop index we're going to set equal to the set of desired values, which we're going to write as a row vector. We can actually do that entry by entry, or we can do that using colon notation. After we write that initial for loop declaration, we're going to define a loop body, which includes executable code we want to repeat multiple times. We end our for loop with the word end to tell MATLAB where the loop body begins and ends. This programming construct is super useful to repeat lines of codes a set number of times. Normally in the loop body, we will have explicit references to the loop index to accomplish some goal. In our first example, we explicitly referred to the value of our loop index in order to print out its value and explore how for loops function. However, let's go ahead and delete this and move on to our second example, in which we're going to learn how to do arithmetic with for loops. Specifically, let's learn to count with for loops. So I'm going to go ahead and start my count at 0. That's going to happen outside my for loop. Then I'm going to tell MATLAB, I'm ready for you to do some repetition using a for loop. So I'm going to type for space. Let's do this index variable equal to k, and let's count from 1 to 8, and let's increment our count using the counting numbers starting at 1 going up to 8 by 1s. Inside this loop body, we're going to increment the value of our counting variable, where the new value of my count is equal to the old value of my count plus 1. Then we're going to end our for loop. Before we run this, let's go ahead and notice that the highlighting here, MATLAB is telling me that I do not have a semicolon at the end. It says terminate statement with a semicolon to suppress output. In other words, if I run this, MATLAB is going to produce this code multiple times. I'm not so worried about that at this moment because the point of this is to explore how for loops work. Let's go ahead and run this and see what happens. So when I push run, notice that MATLAB is executing my script file. The first thing that MATLAB produces is count equals 1. Then I go to the next iteration of my for loop, count gets 2. 3, 4, look at my computer is counting up from 0. Sadly, this code is not formatted to give us insights into what's happening in the background. So let's go ahead and manipulate the loop body to make it a little bit easier. Specifically, we're going to suppress the output and then use the fprintf function to display formatted text. So we're going to say the count is print out a integer value and then go down to the next line. The integer value that we want to print out is count. We'll go ahead and suppress that output, and then we're going to pause the execution of our loop. Let's run this script file again. So notice what happened here. MATLAB ran this script file, starting with line 1. MATLAB set the variable count equal to 0. So right now in memory on line 1, count has a stored value of 0. Then it's going to drop into this for loop and recognize that we're going to run through values of our index variable k. Which values are we going to run through? We're going to run through the values stored in this vector. This vector starts with the value of 1, goes up to 8, and counts up by 1. So this is a 1 by 8 vector, 1, 2, 3, 4, all the way to 8. The moment that we drop into the loop body, remember on the first iteration of this loop, the one where k is equal to 1, the current value of my count variable is 0. So now we're going to overwrite that count variable with a new value. What value is it going to be? It's going to be the previous value, which was 0 plus 1. So in line 3, during the first iteration, I take the 0, I add 1 to it, and then I store that back into my count variable. So now the value of this count variable is 1. MATLAB drops down to line 4 and prints out the count is 1 because the current value of the count variable in that iteration is valued 1. Then it pauses. We are currently in that pause right now. When I push enter again, MATLAB recognizes that we are at the end of the for loop. It does a quick check. Do we have remaining values that the index variable has to take? Well, in this case, the index variable was equal to 1. Indeed, 1 is not the last value stored in my row vector of desired index values, so MATLAB increments the value and then drops back up to line 3. What did line 3 tell MATLAB to do? It tells MATLAB to take the previous value of count, which is 1, add 1 to it, 1 plus 1 is 2, and overwrite that new value into the value of count. Then it drops down to line 4, it says, please print out the count is the current value of count, which is 2. Then it pauses. We're currently in the pause. We can just repeat this 1, 2, 3, all the way until we get to the end or last value in this variable. MATLAB is currently in the last iteration waiting to pause. When I push enter, MATLAB does a quick check to see whether or not the index variable has exhausted all desired values. In this case, it has, so now MATLAB jumps outside the for loop itself. Let's go ahead and take a look at a refinement of this example. Suppose that instead of wanting to count up by 1s, we want to count up by 2s. In order to do this, notice let's start our count at 0. And then every time we run through the loop, instead of adding 1, let's add 2. When we run through this loop, notice that the first iteration adds 2 to 0, which gets me 2. Second iteration adds 2 to 2, which gets me 4. Adds another 2, gets me 6, and I go all the way up to 16, since there are a total of 8 iterations of this loop. In other words, I'm adding 2 to itself 8 times. Yet a third thing that we could do is start at a non-zero value. So suppose we wanted to start at 5 and go up by 4. Moreover, imagine we wanted to do this a total of 10 times. Well, remember, if we add 4 to itself 10 times, that would be 40. But my initial starting value is 5. So my guess is after 10 iterations of this loop, the value of the variable count should be 45. Let's go ahead and check this by running it. So the first iteration, count is going to go from 5 to 9 because I added 4 to 5. Second iteration goes to 13, 4, 4. I'm just adding 4 as many times as I need. Notice there are a total of 10 iterations. 5 plus 4 times 10 is indeed 45, and that's exactly what we see. Let's delete the context of our script file and start with a third example of using for loops. Specifically, we'll study a classic problem in discrete mathematics, which is summing the first n integers. Specifically, if we said n is 1, what happens when we sum the first 1 integers? It's not very interesting, it's just 1. If n is 2, let's go ahead and sum the first 2 integers. 1 plus 2 is 3. If n is 3, let's sum the first 3 integers. 1 plus 2 plus 3 is 6. If we do the first 4 integers, notice we take 6 plus 4 is 10. If we go to the first 5, 10 plus 5 is 15, plus 6 is 21, plus 7 is 28, plus 8 is 36, and so on. In fact, there's a famous formula. If I sum the first n integers, the value of that sum is n outside of n plus 1 divided by 2. One claim that's going to take a little bit of practice to see is that we can actually achieve this type of calculation using a for loop. Specifically, let's assume that we want to sum the first n equal 8 integers. So let's go over to our script file and we'll write n equal 8. Now we'll define a variable called sum, and to initialize this variable, we'll set it equal to 0. Next, we'll use our for loop structure. So we type for space. We'll call the loop index equal to j, and we'll let j run through the counting variables from 1 all the way up to n using colon notation. Remember, if we do not define the increment value, it's going to go up by 1s. Specifically, this vector right here starts at 1 and goes up to n equal to 8. Let's drop into the loop body. In each iteration, we're going to define the new value of the sum to be the old value of the sum plus the current value of the index variable. Then we'll go ahead and end this for loop. Claim at the end of this iteration, we see that the value of sum should be equal to 36, since that is the total sum. Let's go ahead and run this code. Here we've run, and if I type in sum, that thing is stored in memory, and indeed this thing is 36. Here's a crazy idea. If I wanted to count the first 10 variables, I could switch n equal to 10 and run it. In this situation, when I type in sum, notice the value is 55. That's exactly what we expect in our table. table, this value should be 55. I could actually find the sum of the first n numbers where n is arbitrarily large. So suppose I wrote n equal to 100. Notice when I type in sum, MATLAB is going to tell me that the sum of the first 100 numbers is 5050. Let's see if it does the first 1,000 numbers. Let's go ahead and run that for loop. Notice that the sum of the first 1,000 numbers is this thing. Let's see if we can do something insane like 10,578. Let's go ahead and run that. MATLAB does that blindingly fast. I hope this shows you how crazy this is. We just, in a split second, calculated the sum of the first 10,578 numbers, and that value is 559,52331. One thing we're going to note as we get more sophisticated is that it's not always easy to tell whether or not the algorithm that you've written solves the problem that you want. In this case, we have a closed form formula, so we noticed that n was that value. If I go ahead and type in n times n plus 1, and then I divide by 2, notice the sum that I calculated using my for loop is exactly what we expect if we use our closed form formula. That means that it is likely the case for this value of n that my algorithm accurately solved the problem that I wanted to solve. Let's move on to yet another example of how to use for loops. In this case, we'll study a more sophisticated problem along the same lines. Specifically, let's assume that we wanted to sum the first n squares. Here's a table that expands on that problem. So if I sum the first 1 squared, well, 1 squared is just 1. If I sum the first 2 squares, 1 squared plus 2 squared, well, 1 squared is 1, 2 squared is 4, 1 plus 4 is 5. The first 3 squares summed is 1 plus 4 plus 9, which is 14. In other words, it's 5 plus 9. The first 4 squares are 1 plus 4 plus 9 plus 16, or it's the first 3 squares plus 4 squared, so that's 14 plus 16 is 30. 30 plus 25 is 55. 55 plus 36 is 91, and we can continue down. Once again, we're going to learn to recognize this as a classic for loop structure. Specifically, notice that the next iteration is simply adding a value to the previous iteration. Let's go ahead and write this up in our play with for loop script. In this case, we'll assume that we want to add the first 10 squares. So let's set n equal to 10. Then we're going to initialize our sum variable to start at 0. Next, we'll use our for loop structure. We type for space. Then we're going to run through our loop index. We'll start that index at 1 and go all the way up to n. We'll drop into the loop body. In the loop body, we're going to take the previous value of sum and add to that the square of the current value of the loop index. Then we'll go ahead and suppress the output of that and then end our for loop. Let's go ahead and run this code. Notice if I actually print out the value of sum after this for loop has calculated, I get a value of 385. That's exactly what my table tells me to expect when I want to sum the first 10 squares. Let's suppose that I wanted to take the sum of the first 398 squares in the integers. When I go ahead and run this, when I type sum, notice that tells me that the value should be 21094,199. I'd like you to do that by hand if you can. That would be really nice. Recall, it's not always easy to check whether or not my algorithm produces my desired solution. In this case, I'm giving you the closed form example of this so we can check. Let's go ahead and see that n in this case was 398. So we're going to go ahead and calculate n times n plus 1 times 2 times n plus 1, and the whole thing is divided by 6. Notice that the value indicated by my closed form solution for this sum is identical to the value that MATLAB calculated using this for loop. With that, we're going to end the tutorial portion of this video focusing on how to use for loops to manipulate scalar values. Let's do a quick review of the syntax of a for loop. Remember, we're going to start each for loop with for space. Then we're going to write an index variable or a loop index. In this syntax, we're going to set that index variable equal to a row vector of desired index values. That tells MATLAB to set the index variable equal to each individual entry of that row vector. Once we've written that single line, we drop into the loop body, which includes a set of executable programming statements, usually with direct reference to the loop index. We end our for loop with the word end to indicate that MATLAB, everything in between the for and the end, we're going to execute multiple times. The number of times that we execute this code is equal to the number of entries in this row vector on the right-hand side of the assignment operator. Notice this implies that the for loop structure is really, really useful if we have a certain set of code that we want to run a predetermined number of times. One unique feature of MATLAB is that the index value runs through the entries of a vector, and those entries can take any form. This leads nicely into the community challenge. In the comment section below, post your response to this question. How do you know if a problem that you're working on should be solved using for loops? In other words, how do you train your mind to recognize when to use a for loop to solve a particular programming problem? You can write your own ideas in those comments, or you can write links to other people that have good expositions on that topic. Of course, I always welcome your comments and questions as well. Thank you so much for your attention. In the next for loop tutorial, we're going to see how to use for loops to take advantage of vector structures. I'll see you there.